So we have been working on factoring and all that kind of stuff, right? And there's a couple times I've factored things really quick and you're like, whoa, how'd you do that? Well, because I know the pattern. Okay? So there are some patterns that can help us factor. Okay? Now, when you have it quadratic, you could factor it the long way and you get there. But what if I throw a cubic at you? Okay. So, but if you know the rule for difference or sum or cubes, then you can use it. It can make multiplying quicker than having to FOIL it all out. It can also make factoring quicker. So that's what we're here to do today. Maybe. Okay. So the process we're going to be using, we have the identities. We have the following identities. We have a squared plus b squared. That is a difference of squares. Yes? A and b are both squares. It factors to a minus b times a plus b. Those are conjugates. Did we not use conjugates when we did complex numbers? We did. And the whole point of conjugate was to get rid of the imaginary term, wasn't it? Which would have been in the middle term. So those are difference of squares. Now, an example of that, don't keep writing, stop after you do that so you can do the example with me. I have 25x squared minus 36y squared. So that's what we're going to use. Is 25 a perfect square? Yeah. Yes? Is x squared a perfect square? Yeah. Yes? Is 36 a perfect square? Yes. Is y squared a perfect square? Yeah. And actually, I'm going to change this square on the x to a 4. I'm going to change it to a 4. And this is why. Is x to the 4th a perfect square? Yeah, because it's x squared times x squared. Is x to the 8th a perfect square? Yes. It's x to the 4th times x to the 4th. So any even exponent on a variable is a perfect square, correct? Yes? Yes. Any even exponent on any value is a perfect square. So just remember that, okay? So this basically tells me to take the square root of the first term, yes? So what is the square root of 25? 5. What is the square root of x to the 4th? 2. X squared, yes? So it goes x squared in the first one and x squared in the second one. One is going to be positive and one is going to be negative. Now the rule, they put the negative first. Does it matter? Nope. That's why I put the negative second. Just so you see, it does not matter. Got it?
So is this one going to be
6y squared?
6y squared?
Nope. It's going to be 6 what? 6y.
My bad.
Yep.
I forgot we put theirs.
Yep. We only put I wanted to put the 4 on the x so we could see it. Will that work for any difference of squares? Yes. Now do you see how I can factor them so quick when I get to those difference of squares? Yeah. Because I know the rule. The rule is the square root of the first plus and minus the square root of the second. It is that conjugate pair. Convenient, isn't it? So the next one I have the square of a sum. Right here? Yes? So I have a plus b squared, correct? Yes. So this is the rule. I square a, see that? Mm-hmm. I square b, see that? Yeah. And in the middle it's 2 times a times b. Makes sense, because that's when you're foiling and you combine like terms, right? Yeah. But it doesn't have the square of a difference, does it? So a square of a difference, that would be a minus b squared, yes? So again, bless you. It is going to be a squared, and it is going to be plus b squared back here, because a negative times a negative is still a positive, yes? But what's the middle going to be? Minus 2. 2ab. Every time. No matter what. Kind of nice?
Wouldn't it be B squared?
Oh, yes, I said b squared and didn't write it. Thank you. Every time. Would that save you some time if you remembered the rule? Yes. So the example we have is 2x plus 4y squared. So the rule says to square the first term and square the last term, yes?
Yes.
Correct? So 3x squared is what? All right, 3x is 9x squared. Plus back here, 4y squared is 16y squared. I do it in this order. I'm weird. Some people go down the line. Does it matter which order I do it in? No. Okay, so 3 times 4 is? Times 2? 24. So it's plus 24, and there's an x and a y going on, yes? If there was just an x, it'd be just an x, wouldn't it? What would my answer be if I have 3x minus 4y squared? It would just be 9x squared minus 24xy plus 16y squared. Again, why is that last term always going to be positive no matter what?
Because 2 negatives equals a positive.
Because two negatives multiplied together is a positive.
Wait, how did we get 24?
3 times 4 is?
12.
Times 2.
Oh, okay.
Because when I FOIL that, I'm going to have 3 times 4, and I'm going to have 4 times 3, and I'm going to get 12 and 12 both times, which is 12 times 2, yes? Okay, think about like what happens when I FOIL. Bladen, turn around. Okay, now I'm going to erase the last example we did. Am I okay to do that?
Yeah.
Okay, because I don't want it right next to what we're going to go over next. Now, I have the sum and difference of cubes. I don't want you to write this. I don't know. I personally would not write it two different things. This is how I would do it. I would write sum / difference of cubes, and where this I would have plus minus. See that? I would have plus minus, and I would have minus plus. Personal. If you want to write it two separate things, go for it. I like to write minimalistic. But let me tell you what this means. So I have a squared minus b squared. Or cubed, not squared. Woo, cubed. Because this is the sum and difference of what? Cubes. Do you now know why I wanted you to know your squares and cubes last year? It will save you time. So you take the cube root of the first term. So the cube root of a cubed is what? A. You take the same sign. You take the cube root of the second term, which is b. Got it? Now, this is your first term, and this is your second term now. Ready? Square the first. Opposite sign. Multiply the two together, and square the last. See that pattern? I took the cube root, same sign, cube root. Then I only used this after that. Square the first, opposite sign, multiply the two together, square the last. Always going to be a plus because two negatives multiplied together is a positive. So, let's look at the example for 8m cubed minus 27. Is 8 a perfect cube?
No. Wait.
Yes, 2 cubed, yes? Obviously, m cubed is a perfect cube. Yes? Okay. 27 a perfect cube? Yes. Okay, so the rule says take the cube root of the first. So the cube root of 8 is what? So it'd be just 2m. Because the cube root of m cubed is m. Same sign. So what sign? Minus. The cube root of 27? 3. So 2m is my first term, and 3 is my second term now. the cube root of 27 is 3, correct? Squares and cubes last year?
7 and 9 and 3?
9 and 3, yes, but 9 is 3. 27 is 3 times 9, which is 3 times 3 times 3. So the cube root of 27 is 3.
Whoa.
Okay.
Okay, so we square 2m and get what? 4m squared. Bladen, do not turn around. Opposite sign. Plus. Multiply the two together. No, just opposite sign. Don't worry about the sign. So 2 times what? 6m. And then plus square the last. 9. Not negative. Now, the nice thing about this, what if I asked you to solve to find the x-intercepts? Because solving is finding x-intercepts, correct? Guess what? I got over here, I'd add the 3 divided by 2, so m would equal 3 over 2, correct? Over here, I'd have 36. Well, do the factors of 36 add to 6? Factors of 36 to add to 6? No. So I'd have to use the quadratic formula, yes? Now, you don't need to do it, but I want to show you something real quick. I would have negative 6 plus or minus the square root of 36 minus 144 over 8.
Wait, what is this for?
I took 4 times 4 is 16 times 9 is 144. I did the quadratic formula, right? What's going to be a problem with that? Well, no.
These are cute.
What's the problem with that? I don't need to. What's going to happen in there? I'm going to have a non-real solution, yes? Because 144 is bigger than 36. This, guess what, is never going to have a real solution. So your only solution is what? No. M equals 3 halves. So it will never have a real solution. Guys, this second piece will never have a real solution. If I ask you for all the solutions, do you have to give me the imaginary one? Yes, but if I ask for all the real ones or the x-intercepts, is it going to have one there? No. Okay, so let's look at sum of cubes. Same rule. I'm going to erase a little bit above it. Okay, same rule. I'm going to take the square of the first, same sign, square of the second.
I thought we just did that.
We did with the difference. We're going to do the sum now. See that?
So I should erase sum.
No. I said I would write sum. I can't write. Sum, difference of cubes.
So is that
Okay, now can I finish, please? It would be a cubed plus or minus b cubed is equal to a plus minus, that means same sign, yes? Plus minus. Everyone follow that? And then it would be a squared minus plus. What did the signs do?
Flop.
They flipped. AB plus b squared. That is the pattern. So it's the same pattern for both, correct? Cube root, same sign, cube root. Square the first, opposite sign, multiply the two together, square the last. That's what it is. Don't overthink it. Whatever you're messing with, stop it.
Hey,
I need that.
Okay, so Okay, I have 8g cubed plus 64h cubed. Are those perfect cubes? Yes. So, cube root of 8g cubed. 2g. Same sign. Cube root of 64h cubed. 4h. Now, square the first thing.
4G squared.
4g squared. Opposite sign. Multiply the two together. 8gh. Plus, always plus, because the negative times a negative is a positive. 16h squared. That is the pattern. That's it. Cube root, same side, cube root, right?
So the
Square it, opposite sign, multiply them together, plus square it.
So would the answer be GH?
This is the answer. This equals that factored.
I'm so.
So, that's what we're doing today. That's it. All those rules. Okay? So now we've got to use the rules, yes? Okay. So, I have 2x squared plus y cubed quantity squared. That's the sum of squared, right? Square sum, square sum. Okay, square sum. Square sum says what?
Yeah, the a plus b then squared equals a squared plus 2ab plus b squared.
So I square the first thing, yes?
Mm-hmm.
Multiply them together and then by 2? And then square the second. Yes? So that's what we're going to do. So it says square the first thing. Do you want me to write that out? You want me to like write it 2x squared squared? Or it'd be that more confusing?
No.
That's more confusing. Okay. So 2x squared squared is what?
4x
4x to the fourth.
What?
2x squared squared is 4x to the fourth. Okay? Same sign, right? Now I have to multiply the 2 together that's in here, yes? And then multiply by 2. Correct? Well, we have 2 times 1 is 2 times 2 is what? 4. And then your exponents would just, your variables would just be what?
x squared y.
X squared y cubed. So it really, the variables don't change, right? Unless they both would have the same variable. Okay, and then it says plus, right? And square the last. Y to the 6th.
So just
Because y cubed squared, you multiply them. So we just followed the rule, didn't we?
Yeah.
Okay, so let's check and make sure we did it right. So it's 2x squared plus y cubed, right? And 2x squared plus y cubed. Because this is what you had to do the other day, wasn't it? Okay, so then we have this, which is 4x to the 4th plus 2x squared y cubed plus 2x squared y cubed plus y to the 6th. And is this 4xy squared? So was that easier to know the rule? Yes.
What is that last exponent?
This one? It's a
6.
3? This one? This is a 6.
What?
Your 3 looked kind of.
I know, my pen kind of dragged off. Yeah, but he said the last exponent, so I was like, oh, that's a 6. But
I meant in the box.
okay. Yeah, it's easy to do in your head. Yes. But if I knew the rule and did it enough, would it be faster? Yeah. Okay, now we've got something a little bit different.
Yeah.
Hmm.
Isn't that just 41 times 30?
Well, It is 41 times 31, but I don't want to do 41 times 31. Oh, 39. I don't want to do that. That's like a lot.
That's easy.
Isn't it 40 minus 1 and 40 plus 1?
No.
Isn't it?
Oh, what is that?
Mrs. Mint.
Oh yeah, that is, but no. Why would
Okay,
we do
guys,
that?
watch. Is that not what that is?
Yes.
Sure.
Okay, what's 40 squared?
80 to 1600.
160.
Yeah.
What's 1 squared? 1. So the answer is, how much easier was that?
I'm just
Nah.
gonna multiply
That-
the-
no, you're cheating this
You're
week.
taking
You're
away
cheating.
what I learned
But can't we
in
just
elementary
multiply?
school.
Yeah.
for reason.
Okay, the other way we could do that, could you make this 40
Yeah, 16.
times 39
Mrs. Mint, wouldn't it be 60?
and 1?
Not 160.
Yeah, 1600.
Oh, 1600, sorry.
Yeah, Blaine.
So it would be what? 1599?
5.
Sorry, I forgot a 0.
Oh, no.
The other way I could do it is this. Yes? Could I do it that way?
No. Why? Why would
Okay.
you do it that way?
Well, because honestly, I can multiply by 4 pretty quick. 6 carry 3 is 50, so it's 1,
Can't we just
5,
put it into our
6
calculator?
plus 39.
We don't
Oh,
do
and a
that.
0.
I know the answer.
plus
It's
39.
159.
Okay, guys, these are ways for you guys to multiply without taking it back to second grade. They are ways to make, you ask why I multiply so quick. I do things like this. I make it into 40 and 1 and I add them together and I get 1599.
I get the top
I
one.
like the
Okay.
first one.
Wait,
before
yeah,
the
The second one, can we
Can't
just
you
Okay.
just do? Can't you just do 40 times 40 and then take one away, since it's 40? And
That's what we
39,
did.
Or 41 and 30.
That's what you're doing.
That
That's
is
what
so
you're
weird.
but this is what you're doing to do that. Okay? So, with the numbers, guys, with the numbers, I want you to be a little open-minded because when you're multiplying, when we get further on in Algebra 2 and Pre-Calc and Calc, if you're spending all this time to multiply 41 times 39 when you could just do it a quick way, shouldn't you be doing it a quicker way? Yes. You need to grow in your math. Okay, so use polynomial identities to multiply. So, what do you notice about these two things?
They're saying
They're exactly the same except for what?
the numbers.
Okay, are they conjugates? Difference of squares?
Yeah.
Yes? So your first thing said, if it's like this, if it's like this, that's factored, yes? What's it look like when it's multiplied? I just square the first minus the square of the second, yes? Okay, so let's make this easier than foiling it all out. So I have 3x squared plus 5y cubed, 3x squared minus 5y cubed, so I have that conjugate pair. So all that means is square the first.
It's gonna be
5x4.
9x to the fourth minus the square of the second.
25y to the 6th.
Okay, is that quicker than foiling that out?
Yes.
Yes. That will save you tons of time.
Wait, is that the answer?
Wait,
Yes. So you just
so you
Went
just
that
add
way?
the exponents, not multiply?
When you multiply exponents, you add.
multiply.
So when I have 3x squared squared, it goes to both. So it's 9 and 2 times 2 is 4.
It's that simple.
I get that.
Why didn't you tell me that?
Like,
And then this is 5y cubed squared is 25 and 3 times 2 is 6.
I'm not. I'm probably not gonna get it either.
5y.
Yeah, and then you would add them. Okay. So if you're just doing it that way, you would add them. Did it my way, you'd multiply them, but you're still, it's squared, so either way it's going to be fine. Okay.
Miss Smith.
What?
Why do our exponents? Never mind. That makes sense. That they have to equal each other.
Are good?
Isn't 3 times 3
I was like,
9?
wait a minute. That has to be. It has to stay equivalent.
It's
to
not
the-
3 times 3. It's y cubed times y cubed. We add exponents. It is y to the 6th. You add exponents when you're multiplying. Okay, so we have 12 plus 15 squared.
12 plus 15
Okay.
is 27.
The squares is sum, yes? Okay, so you have 144, yes?
Yeah.
Plus,
Wait, what do you get one?
and then 225.
Yeah.
Now I gotta do this and then multiply by 2, yeah?
Yeah.
But you know what?
So 27.
No, that won't work. Okay, you wanna multiply by 2 first or add them first? Add them first. So you get 27 times 2 is 54. So I get 4 plus 4 is 8 plus the 5 is 3. Carry 1. I have 3, 8, 12. Carry a 2, 1 is 2.
Hang on.
Huh?
She just added it horizontally
Huh?
over.
But I think I lined something up wrong. I think I lined something up wrong.
Yeah.
12 times
Okay,
12.
so 12 squared is 144. Okay, that is 27 times 2 is 454.
I thought it was A times B times 2.
Yes, it is. Thank you very much. Not adding. I was like, something's wrong. My number wasn't big enough, was it? Okay,
It was
So-
smaller than.
now I am honestly, guys, 12 is 10 and 2, yes?
Yeah.
So 10 is 150,
Yeah.
yes? 2 is 30.
What?
2 times 15 is 30.
Oh, yeah. Sorry.
So I get 180 times 2
Yeah.
is 360.
How did you get 150? Did you multiply the two numbers?
I took 12 and 10 and 2. So 10 times 15 is 150. 2 times 15 is 30, so it's 180.
Now we times that one too.
No, now we timed the 180 times 2 is 360. Okay, so then I have 4 and 5 is 9. I have 2 and 6 is 8, plus 4 is 12. And 1, so that's 3, 6, 7.
729.
729. Okay, just different ways to do it. Okay, guys, I just want you to know that as long as we follow math procedures, can I do a lot with my numbers to make my life easier? Yes. Okay, so I challenge you today when it tells you to do something to try it. Try something different. Okay, you might see a method that you would like to use to make multiplication quicker. I always am dividing 2-digit numbers up. Always. If I have to take 57 times 63, I'm multiplying by 60 and by 3. I don't want to multiply by 63.
I did the same thing. I did
Okay.
my baby's math last night, actually.
Or I do 50 and 7. Could I do 50 and 7? Yes. I challenge you to find better ways to do your math. Okay? So, next example, it says factor. So we're going to go, we factored our examples, right? We went from left to right. The last one we went right to left. So we're going to factor. So I see a minus, so I'm hoping it's difference of squares. Anybody else?
3 and 5.
Okay, is 3 a perfect square? Is 25 a perfect square? Okay, well, m to the 4th is a perfect square because it's even, right? Yes? And n to the 6th is a perfect square because it's even also. Okay, so difference of squares is just parenthesis, parenthesis, right? One is a plus and one is a what? Minus. And we just take the square root. So the square root of 9m to the 4th is what? 3m squared. So then I put 3m squared in the first one and 3m squared in the second one. What's the square root of 25n to the 6th?
5 and
5n to the
second.
3rd. You're dividing them by 2, correct?
Yes.
When you're taking the square root. And then we're done. Now, if I needed to set those equal to 0 and do all I could, then I would go from there, but they aren't linear, they're cubic, and then you'd have to go for the other things. Okay, x cubed minus 216. I see an x cubed, I'm hoping that 216 is a perfect cube. Is it?
Yes.
What?
16. No. Yeah.
6. Just 6, isn't it?
Oh, yeah.
Isn't it 6?
Yeah.
Yeah. Okay, so the cube root of 216 is 6, right?
Yeah.
I knew it was 6.
Okay.
So it's X minus 6.
So it's x minus 6. That's my starting point, right?
Yeah.
And then I square the first thing. So x squared, opposite sign.
Plus 36.
Was it 36? Is that the rule?
Or, yeah.
I'm asking you. You guys have it written down. Is it 36?
You take, this is the difference.
It's 123.
You have to take A and B times
Or,
A.
yeah.
A and B. So it's 6 what? X.
X.
All I wanted you guys to do is say, yeah, it is. I looked at my rule. That's all I wanted. And then I square the last, so I get what?
36.
Plus 36. And I'm factored. I'm done. Now, you don't have a way to factor this. Your other only option that you'll learn after we come back from break is long division and synthetic division, and I much rather know that rule than do long division and synthetic division on a polynomial. Okay, next one. I got perfect cubes? Yeah, because they say cubed, right? So the cube root of 11 cubed is just 11, same sign, 5, right? Okay, this is quicker because I don't want to cube numbers. So 11 squared is 121, opposite sign. 5 times 11 is 55, and plus 25. Bless you. So this is 15 in the first one, yes? And the second one is negative 55, bless you. And 25 is negative 30, yes? Oh, that would be 16.
What are you doing?
191.
191? No. 121
What?
minus 30, try this 91.
Or, yeah.
When you do minus 55,
I took minus 50. Carly, ask a question, listen, please. Negative 55 plus 25 is negative 30. I just reordered them.
okay.
Okay, so now I have to do 16 times 91. I could do 10 plus 6 and multiply, or I could do 90 plus 1 and multiply.
That one better.
You guys like 90 plus 1?
Yeah. 'cause
Okay.
you don't have to do 6.
So 9, oh, but I hate multiplying by 9. Okay, so 9 is 54, right? Carry a, so 1440 plus 16 is 1456. So this answer is 1456. So again, on the number ones, guys, I know that you could cube 11, and I know that you could cube 5. Cubing 5 isn't bad. Cubing 11 might be a little bit, I know it's 1331, but anyway, you don't know that. But,
Now we do.
yeah, now you do. But use the rules to try to stretch your brain, okay? You get what I'm saying? Try.
We're done.
We got more examples. We could keep going.
No, I gotta go. We're good.
Oh, actually, I see how that.
Okay. I honestly, doing more examples is not going to kill you, is it?
Yes, it is.
Okay. You're not going to have time to do much with your homework anyway.
Yeah.
We got 5 minutes.
Yeah. So
Max 5 minutes.
m
Four
to the
problems.
8th minus 9m to the 10th. I see a minus. So I'm hoping for what?
Oh,
Difference of squares.
Yeah.
Is it?
Yes.
Yeah.
Yes, because both exponents are even and 9's a perfect square, right? Okay, so try it on your own. Oh, shoot.
I hope I did this right.
How'd it go?
I did it right.
Good job. Okay, did it go pretty easy? Okay, what about the next one? 27x to the 9th minus 343x to the 6th.
Can't you cube root that?
We can. And that was what I was going to say. It's not perfect squares because you have an exponent of 9, right?
Right. Well, in
But could I
27
divide them by 3 and they'd be perfect cubes?
Yeah, so
Yes.
it'd be 9x cubed.
Nope.
What?
Nope. What's the cube root of 27, guys?
4.
No,
No.
3.
3.
Oh, right.
So it'd be 3.
You said divide by 3
Shut up.
though.
No, the exponent.
Oh.
Okay, 3y to the third minus. Okay, we got to figure out the cube root of 343, don't we?
It's 7, isn't it?
Huh?
Isn't it 7? No.
Oh, yes, it should be x.
It's not 7.
Okay,
Yeah, isn't it 7?
Shut up.
so let's see. I think it is.
Yes, it's 7.
Okay, so 7y to the second. Okay, focus, guys, so we can get through it.
6.
So we have 9. 9. 3 times 3 is 9. 3 times 3 is 9.
So it'd be
X to the 6 plus 21 x cubed y squared plus 49 to 9. 49y to the fourth. We got one more and we're going to do it. Okay? Because it can't hurt you to see more examples. So what is the next one going to be? The cubes. Yes?
Sum of cubes.
Sum of cubes. So I have 12 plus 2. Yes? Okay, 12 squared is
144.
144. Opposite sign. 2 times 12 is
24.
24 plus 4. So negative 24 and positive 4 is negative 20.
124.
Okay, so I have 14 times 124. And I love all these extra marks. And I'm going to do 14 and 10 and 4. How about you guys?
Yeah, sure.
So 1, 2, 4, 0 plus 6, 56. So I have 1, 2, 9, 6. That's how I multiply that quick. You ask, I'm showing you.
You just gotta be smart.
Where did the 56 come from?
Not all of us are math
4
teachers'
times-
daughters.
Oh, I took 4 times 14. It should not be
How is
4
that?
times 14.
Yeah.
Okay, this is nothing to do with being good at math. It is using it's 6, 9, 4. How about that?
Smart.
So 6, 3, 7, 1. Sorry, I multiplied the wrong thing by 4. So please try to use those. I'm going to tell you right now the difference of squares you're going to have to use. The sum and difference of cubes, the quicker you can learn them, the better your life will be because they're going to keep reoccurring just here or there.
Tyson, the bell spot.